In this video, we're going to look at integrating trig functions. Now, remember from our differentiation, when you're doing calculus, which is differentiation or integration, trig functions must be in radians before we get started. Okay, remember, integration is just a reverse process of differentiation. So we know that if you differentiate sine with respect to x, you get cos. Therefore, if you integrate cos with respect to x, you get sine plus your constant of integration. Likewise, we know if you differentiate cos with respect to x, you get minus sine. Therefore, if you integrate sine with respect to x, you don't just get cos, you get minus cos. So integrate cos, you get sine. Integrate sine, you get minus cos. And last one, we knew that if you differentiated tan with respect to x, you get sec squared. Therefore, if you integrate sec squared with respect to x, you get tan. Okay, we're going to look at a couple example here, which just says consider integrating cos 3x. Now remember, the angle bit always stays the same. So when we integrate cos, we're going to get sine, but we're also going to get 3x. So sine 3x is going to be in our answer somewhere. We just need to figure out what extra bit there is, what other number is multiplying out the front. So we do this by, it's really integration by inspection. So you have an idea really of what the answer is going to look like, and you try and differentiate that. So if I differentiate sine 3x, what I get is 3 cos 3x. So that's how I've done that. You differentiate with respect to the sine, you get cos. The angle stays the same, and then you differentiate with respect to the angle. So differentiate 3x, you get 3. So differentiate sine 3x, you get 3 cos 3x. So we haven't got what we wanted. We didn't want 3 cos 3x. We only wanted 1 cos 3x. So this thing effectively is 3 times too big. So I'm just going to add an extra line in here. So if I had differentiated a third times my sine 3x, so this is now a third as big as what I had originally. So that will make my answer a third as big as well. So that's just going to give you cos 3x. So I've shown that if I differentiate a third sine 3x with respect to x, I get cos 3x. Therefore, if you integrate cos 3x with respect to x, you get 1/3 sine 3x plus c. Okay, it's fine for you to work through that every time, but it's quite long. So a couple of extra wee results which are good for you to learn. If you integrate cos, and I've said mx, so m is just a constant. If you integrate that with respect to x, you'll get 1/m sine mx, and remember plus your constant of integration c. And also if you integrate sine mx with respect to x, what you're going to get is minus 1/m, and it's cos mx plus c. So two very useful results, definitely will speed you up as you go through these questions. Okay, in the same thinking, there's just 3 more results. If you integrate cos ax plus b, you get 1/a sine ax plus b, and then plus your constant integration. Integrate sine of ax plus b, you get minus 1/a cos ax plus b plus c, and likewise if you integrate the sec squared of ax plus b, you'll get 1/a tan ax plus b plus your constant integration c. Okay, we're going to go on and look at a few examples here, and then we're ready to do our questions. So just some of these are very easy, some of them will take a wee bit more thinking, so just be very careful. Okay, nice easy start for us. First one, just integrate cos of 5x. So that's like integrating cos of mx, we said was equal to 1/m sine mx. So here it's just equal, jump straight to the answer, it's 1/5 sine 5x plus c, and that's it done. Okay, this one, this is integrating your sine mx example. So if you integrate sine mx, you'll get minus 1/m, and our m in this case is 0.5, times cos mx, so m in this case is 0.5x, and then plus your c. So obviously you're not going to leave this. Minus 1 divided by minus 1 divided by 0.5 will be minus 2, and then cos of 0.5x plus c. Okay, and the last one over here, it says 2 cos of 3x plus pi. So you can remember, if you integrate it, forget about the 2, integrate the cos of 3x plus pi, you're going to get 3 on the bottom line times cos of, times, get rid of that, that's nonsense. You're going to get your 3 in the bottom line times sine of 3x plus pi. And then we've also got this 2 multiplying here, so the 2 goes in front as well. So it's really 2/3 times sine of 3x plus pi. And I've forgotten my constant of integration. I would have lost marks there. And that's it. Okay, this example, we're integrating sec squared. And it's sec squared of 4x plus 1. So it's just going to be 1 over 4 times tan of 4x plus 1. Just always be careful to have the brackets, and then plus your constant of integration c. Right, a very important example, this one. It's our definite integration example. Notice our things are, it's pi over 6 and 0, so pi over 6 is definitely in radians, so we're all good to go. And we are going to integrate this. It's going to be a square bracket, 6 upon it's going to be a half sine 2x, so it's just 6 over 2 times sine 2x, and my limits are now over at the right hand side, so I have pi over 6 and 0. Okay, that's just as a mess, so tidy up, that's going to be 3 times sine of 2x, and that's pi over 6 and 0. So 3 times sine of, put your pi over 6 in, 2 times pi over 6 is pi over 3, sine of pi over 3, calculated in radians mode, remember, will give you root 3 over 2. So the first bracket is just going to be 3 upon root 3 over 2, and your second bracket is 3 upon, and sine of 0 is just going to be 0, and if you just sort that out, then that's just going to be 3 root 3 all over 2, and that's that example done. Okay, a nice example for us to finish on here. It says, how would you go about integrating tan squared of x? Now, we don't know how to integrate tan squared of x, but we do know how to integrate sec squared. So if you think back to your identities, I always start by just writing down the most basic one, which I know, which is sine squared plus cos squared is equal to 1. And then to get the sec one, I'm going to have to divide through by cos squared. So sine squared divided by sec squared is going to give you tan squared. Cos squared divided by cos squared is going to give you 1, and 1 divided by cos squared is going to give you the sec squared x. So we know that tan squared plus 1 is equal to sec squared. That means that tan squared x is going to be equal to sec squared x minus 1. So here we can rearrange our integration, or rewrite our integration, I should say, as sec squared x minus 1 integrated with respect to x. And then we can integrate. If you integrate sec squared, you'll just get tan x. Integrate the minus 1, you'll get minus x. And then, of course, plus your constant of integration, c. Okay, folks, as you can see, I've written down already. You're now ready to do topic 7, exercise 5.